Welcome to the Code with Jason Meetup. Thanks for being here. I have a special announcement before we get started with tonight's topic. I am putting on a conference. It is called Sin City Ruby. It's the second Sin City Ruby that will be happening. The first Sin City Ruby was in 2022, obviously in Las Vegas. Skipped 2023, but I'm doing it again in 2024. The dates are March 21st and 22nd, 2024. That's a Thursday and Friday. And tickets go on sale July 17th, 2023. So if you happen to catch this video before that date, tickets will be available. And the best way to find out is to get on my email list. So if you go to codewithjason.com, it's not too hard to figure out how to get on my email list one way or another. So I'll be sharing info there on how to buy tickets. There's also sincityruby.com. You can go there, and that's where the ultimate link to buy tickets will be. And speakers to be announced soon. Okay, anyway, that's my conference that's coming up. Tonight we're going to be talking about how to fix a bug, which might sound like a topic that there's not a lot to, but there's a lot to it. And I think a lot of people would benefit from what you might call a more formal education around bug fixing. Because there's a lot of misdiagnosing of bugs, and there's a lot of fixing of bugs that doesn't actually fix the bug. Maybe it introduces a new problem. And then the process of applying the fix, sometimes that's pretty rocky too. And so there's some strategies for mitigating the risk of when you apply that fix. So the first thing I'll say is this. I divide bug fixes into three distinct phases: reproduction, diagnosis, and the application of the fix. So let's talk about those three things in order. So the first one, reproduction. Even before you try to reproduce it, you have to start being careful right away. And this whole thing is an exercise in pure logic and epistemology. So right away, you have to start being careful, because if Carl comes to me and he says, "Hey, I'm trying to use a Helmet's train site," and he'd tell his Helmet, I can't log in. What belief should Helmet form from that report? The correct belief to form is not that Carl can't log in. The correct belief to form is that Carl says he can't log in, because that's all you can know for sure. And that's maybe not the best example, because if Carl says he can't log in, that's probably the case that he can't log in. But it's very, very common for people to report bugs and they say X is wrong, X is going wrong, but that's not actually the case. So sometimes people's reports are just not true. Obviously not because they're lying, but just because they're saying something that they believe to be true, but is not actually true. And then sometimes a bug report will come along with its own diagnosis, its own armchair diagnosis from the reporter. The reporter will say, "I can't log in because we released this other feature yesterday, and that feature is breaking the login now." And you have to be really careful with that too, because it's easy, especially when it sounds very plausible. Oh, true but not accurate. That's an interesting phrase, Carl. A lot of times people will give you a bug diagnosis or an explanation that sounds very plausible, and there's not a clear distinction between the report of the symptom and the diagnosis. They might say something like, "Hey, that feature we released this morning, it's not working right. It has this certain symptom." And so you say, "Oh, okay, that feature we released this morning is causing a problem because we released it at 9:18, and then at 9:22, this problem started happening. okay, the feature released this morning is causing a problem. Unbeknownst to both of you, it's only a coincidence. And the feature that was released this morning has nothing to do with the bug. And so what was reported to you was a bug. There really was a bug that was happening, but it came along with this diagnosis. So you have to be so careful, because that story I told just now was pretty plausible. We released a feature, it's not working right. But that's not the truth. So again, this is an exercise in logic and epistemology. And if you go study those things on their own, independently of programming, you can bring those skills back and they help a lot. Okay, so the first step in reproduction is to just be very skeptical and very careful about how you form your beliefs about what's true. The next thing, of course, is to try to reproduce the issue, and do that in a very systematic way. You want to list out the reproduction steps and perform those steps, and of course make sure that you can do that consistently. Because if you can't consistently reproduce the bug, then you can't, or I'll put it this way. If you have to have a way to know after you apply the bug fix, to know whether your application of your bug fix was successful or not. And so I'm hesitant to say that you have to be able to reproduce the bug consistently. It's always nice when you can, and that's generally always preferable, but it's not always possible. But that's the ideal, is to be able to reproduce the bug consistently, and you want to write down those reproduction steps. Okay, so now let's talk about the diagnosis. The diagnosis is probably the most important and meatiest and perhaps least well understood and generally least well performed step of the process. And I'm going to assist myself by pulling up an article or two of mine, and I'm gonna refer to these. So the most common method of bug diagnosis in my experience is guessing and checking. And that's not necessarily the worst thing in the world, but it's often not very efficient. I think this is attractive to people because quite a lot of the time, you encounter a bug and you have an idea right away of like, oh, I bet that's this. And a lot of times you're right. And a lot of times it's worth checking. But the problem happens when you say, oh, okay, I know, it's probably this. And then you check that and it's not that. And you're like, oh, oh, well, maybe it's this other thing. And then you check that. And then you just keep this cycle of you just guess and guess and guess. And you're guessing like 5, 10, 15 different guesses. After a while, it's not such a smart way to go anymore. So I think if you encounter a bug and you have like an intuition about what it is, and it's reasonably cheap to check that intuition, then by all means, look into that and check those first couple guesses. But that's not really that's not a systematic strategy for nailing down the bug. You have to try the Hail Mary once, Mike says. Yeah, I agree. I think of it like playing the lottery versus working for a paycheck. So guessing is like buying a lottery ticket, and it's attractive because it's easy. You can keep making guesses and it's easy, but you're not likely to win, except maybe on those first couple guesses. But if you debug systematically, it's more like working for a paycheck, where you're not going to have that bonanza where you had very little effort and you get the payoff, but you win with certainty, and that's a lot better. Okay, so we talked about guessing. Oh yeah, one of my big bug diagnosis principles is that it's much easier usually to find where a bug is than to find what the bug is. And then after you figured out where the bug is, the what part is quite often plainly obvious. So I see this a lot. A developer will get an error message on their screen. They'll read the error message and say, what could this mean? What do we do in the last 20 minutes? What could this be? And I think that's quite often not very efficient, especially when it's like a bug of something you haven't touched in a while. And it's a lot faster especially when it's a really tricky, mysterious bug, a lot faster to find out where the bug is than to find out what it is. So don't think too hard. Again, back to my principle that I've shared a number of times about always trying to lower the cognitive burden to everything you're doing. So trying to think about what a bug could be, that's too high of a cognitive burden. It's much easier to try to find where. And my favorite technique for finding where a bug is what I call binary search debugging. So you guys might be familiar with binary search. And I'll do a quick illustration. This might be fun. Hey, Carl, I'm going to guess when your birthday is. And all you have to do is tell me whether your birthday is before this date or after this date.
Okay, ready.
All right. So is it before July 1st?
No.
All right, there's one guess. What's halfway between January 1st and July 1st? January, February, March. Is it before April 1st?
Well, your first question was, is it before? And I said no. So I'm hoping you're going the other way. Otherwise, we're going to be guessing for a long time.
Is it before? Wait.
You said, is it before July 1st? And I said no.
Oh, whoops. All right.
So...
Excuse me. Okay, July, August, September, October. Is it before October 1st?
No.
Okay. All right. So October, November, December. This is why finding bugs is hard.
Right.
Is it before November 15th?
No.
Oh, wow. Okay.
This is the long end of the beach research there.
So there's like 45 days left.
Yep.
Half of 45, we'll call it 22. December 31st minus 22. December 9th, let's say. Is it before December 9th?
Yes.
Okay, it is before December 9th.
Yes.
So now I know it's between November 15th and December 9th. Okay.
Yep.
And that's like 15 plus 9 is 24. Let's do November 15th plus 12 is November 27th. Is it before November 27th?
It is not.
Okay, that's 5 guesses.
You're getting there.
Yeah. Okay, so we've narrowed it down to November 27th to December 9th.
Mm-hmm.
That's like 10 days. So let's add 5. Let's subtract 5 from 9 to get 4. Is it before December 4th?
It is not before December 4th. It is not after December 4th either.
I see. It's December 4th.
Correct.
I lost track if that was my 5th or 6th guess.
I think that's 6.
But I think the maximum number of guesses needed is like 9, because that's the maximum amount of times you can divide the year in half before you end up with just one day. So, I can't really do an analogy where like I would try to like figure out Carl's birthday by just thinking really hard or something like that. But with code, I do the same thing. So like I do that on the scale of like a file or an entire code base or time. And often in a diagnosis project, I will use all of those. So git bisect works by the same binary search principle that I just used with Carl's birthday. And so if I know that, and again, I have to have a high degree of certainty about this, but if I'm very confident that the bug was not present, let's just say January 1st, and the bug is present on December 31st, then I can narrow that down and do exactly what I just did with Carl's birthday. When I was interrogating Carl just now, I was performing a test each time, a yes/no test. The test I was performing was, is Carl's birthday before this date? But then when you do a binary search on your code, when you do a get bisect, the test you perform is the bug present on this commit? And if it's yes or no, I made a mistake with Carl's and I went the wrong direction, but you take the half where the bug still is, because you can eliminate the other half, and then you just do that until you end at one commit, and then Git can tell you that that commit is the first bad commit. And sometimes your job from there on out is easy, and sometimes it's not. It depends a lot on the size of your commits. So this is why I always encourage developers to make small atomic commits, because these bug searches have to happen kind of a lot. And so if you land on a commit and it's small and it's only about one thing, then it's usually pretty clear. There's not a lot of search area there to figure out what went wrong. Whereas I come across commits sometimes where it's like, oh, okay, I found the offending commit. And then I look at it and it's just like, it's like, oh no, good luck to me finding the needle in this haystack. So that's a helpful habit to have, of having small atomic commits for that reason. Let's see, we're talking about binary search. Okay, so that's searching in time. And then let's talk about searching in a file. So if I have reason to believe that a bug lies in a certain file, I will maybe delete half that file. And then same thing, perform my yes/no test. Is the bug present? Delete half the file, perform the test. Is the bug still present? No? Okay, I'll go back to that first half, delete the second half, perform the test again. Is the test present there? Or sorry, is the bug present there? Yes. Okay, well, I'll divide that in half, and then I'll repeat. With the test of Carl's birthday, the smallest, the atom there was a day. And then with get bisect, the atom is a commit. And then with searching within a file, the atom is a single line. And when you've narrowed it down to the line, then it's usually pretty clear what the bug is. And sometimes you have to get creative and clever with how you divide things up. Like sometimes you can't just delete half a file and things still work. So sometimes you have to be a little bit smarter about it and say, oh, I'm just going to delete this big chunk. It doesn't need to be exactly half. You can still apply the same principle. And then you can apply that same idea on an entire code base. And that you have to maybe use a little bit more thought. You have to try to come up with a test you can perform that says, does the bug lie in this large area of the code base, or does it not? That's a little bit harder for me to give advice about, but I think you guys can understand the principle of doing it, even though I don't have an example of exactly how you would do that for a certain area of the code base. But same idea. And then maybe, I spoke in the terminology of atoms. Maybe the atom in that case would be a single file. And then once you find the file where the bug lies, then you can perform that same process on that file. So that's part of the diagnosis. Let me just skim my own blog post here and see if there's anything else I wanted to say about that. And I don't think there is. That's my main go-to arrow in my quiver is the binary search debugging. Because again, it's easier to find where a bug is than what a bug is. And for me, I think the most efficient way to find where a bug is that binary search method.
what about Jason? What about writing tests, right, that reproduce the problem? And maybe
Yeah.
first it's a kind of an integration or system level test, and then you kind of maybe go down to the controller level, or maybe that goes all the way down to the model level test. I don't know, but I kind of think of the stack, the call
Mm,
stack is kind of the thing that I bisect and kind of try
okay.
to get closer and closer to the point of execution where it's failing.
Yeah, tell me more about this. I can understand the general gist of what you're saying, but I'm not quite grasping the details yet.
Yeah, if I could paint a picture for you. I mean, and so this is an IDE thing, right? And I know that people are pseudo religious about IDEs versus Vim and all that stuff. But in RubyMine, I can, with breakpoint debugging, I can, set breakpoints at various places in the call stack and just kind of visit each place sequentially and see where values start to get weird, right? Because there, I've not only have the breakpoint on the line of code, I've also got the display beneath it. What are all the present variables? What are their values? What's the call stack, and where are you in the call stack? So
Yeah.
it's much more elaborate tooling, but once you become comfortable with it, it, it gives you a really interesting REPL. It gives you a really interesting way to kind of iterate through the code.
Okay. Yeah, I have little experience with that. I remember using Borland Delphi back in the late 90s and early 2000s, and I did some of that breakpoint style debugging, but for whatever reason I've abandoned that and I only use puts debugging, print debugging, that kind of thing. So I have nothing smart to add to that comment. I'll just say listen to Mike because that's probably a good idea, even though I don't do that myself. Um, you mentioned testing, Mike, and that's a that can obviously be helpful. If you have an automated test, you can if you don't have an automated test yet, you can maybe write a test that fails when the bug is present. And then when you're doing, for example, your git bisect, you can test for the presence or absence of that bug more easily.
Yeah, I think that was my larger point before I went off into IDE land was just that if you can produce a failing test, I go and have a coffee because I'm like, this bug is done. I just, I've got to, once I have a failing test, it's not long before you find out what's going on.
Yeah. Yeah. And I think if you have a failing test that fails when the bug is present and passes when it's absent, then by definition, you have diagnosed the bug. Is that a true statement?
I think you've more, if I'm able to write a failing test that reproduces the bug, I know what neighborhood to look in. And that's why I say so that might first be an integration test, right? That may cover multiple controller actions, right? But then I kind of figure out,
Yeah.
well, stuff is going south in this controller, for example. Or when I save this model, there's a weird side effect that I wasn't, anticipating.
Yeah. All you need in order to write the test is to know the reproduction steps. You don't have to have it diagnosed at that point in time.
Right, right. Just have the right values that you kind of plug into the factories or whatever, right? That kind of mimic the state of the world before the bug happens. And then if you can do that, get a failing test because the test has the right values to reproduce the erroneous behavior, then finding the erroneous behavior becomes anticlimactic, I think.
Yeah. Um, and that reminds me, I actually often do this, or I have in the past. I don't do this kind of work. I'm not really a programmer anymore, oddly. But I would do that when I would get the reproduction steps, or when I would figure out the reproduction steps myself, I would translate that to an automated test. And one of my other like core programming principles is separate the what from the how. And so if I capture a bug in an automated test, then I can forget about the reproduction steps. I can forget about all that, and I can clear my mind and move 100% to the diagnosis stage. And that makes that, again, that lowers the mental burden for the whole endeavor. So I really like to do that.
You've been talking a lot about flaky tests lately
Yeah.
in your content, right? Like, I would assume that if you have a flaky test, that doesn't mean you've diagnosed the problem because you don't know if it's the test or the bug, right?
Yeah. And Ryan, I recently recorded a podcast episode on diagnosing flaky tests, and we went for an hour and we ran out of time, and we got like only a small portion of the way through. But all these principles that I've shared just now apply to diagnosing flaky tests, because I consider a flaky test a type of bug, and I use that binary search method all the time to nail down where the source of that flaky test is. The big difference with flaky tests is that they're so hard or impossible to reproduce, and that throws a lot of difficulty into the whole thing.
Right.
Yeah.
So the reproduction, right? If you can run the test and it reproduces the same result over and over again, then I think what you said was true. If not, then you're sort of back to the beginning.
I believe so. Okay, so there's reproduction, diagnosis, and then the application of the fix. Part of the application of the fix, again, is at the beginning having your reproduction steps that you feel highly confident in. Because you have to have a test you can perform before and after that tells you whether the bug is present. So once you've diagnosed the bug, I think it's a good idea to make the smallest possible intervention that can fix the bug. So in the course of fixing a bug, it might be the case that I've needed to like do some refactoring to understand a certain area of code, and I've gone down some various paths that I thought would be fruitful that turns out they aren't, but they were still improvements, so I kept them. Whatever. I've changed all this stuff. But at the end of like 4 hours of working, I realized that, oh, okay, this one line is all I need, and that fixes the bug. Even though I ultimately do want to keep everything I've done, I'll actually start over and make a new branch off of master that just contains like that one line or whatever the absolute minimum is in order to fix the bug. And that again goes back to the idea of atomic commits, atomic changes, all that stuff. Because if it turns out that my bug fix introduces a new problem and I need to roll it back, I want to just roll back my bug fix alone. I don't want to roll back my other improvements too and throw out the baby with the bathwater. So that's part of it. As far as applying the fix goes, oh yeah, I want to verify that in production. Before I deploy the bug fix, I want to perform my reproduction steps in production specifically, deploy the fix, then perform the same reproduction steps and verify that the bug is now absent. And I think maybe that's most of what I want to say about the application of the bug fix. I'm going to pull up another one of my own blog posts to remind myself what I think about that. But as I'm doing that, does anybody have any thoughts on applying a bug fix? Anything you guys think I might have missed? Okay. Yeah, I referenced my own article, and that was basically the gist of it. Make sure that you perform the test both before and after the application of the bug fix. And this sounds like just common sense, but like you'd be surprised how often people just like at the beginning they like don't try to reproduce it, then they just diagnose it by making an assumption, and they don't even take the steps to verify that their assumption about the cause of the bug is correct. And then they throw out the bug fix and don't even perform a test afterward to verify that it worked. And that's why you have so many situations where people apply a bug fix and then it doesn't fix something and they have to try again. And it's just there's just so much waste involved. So even though some of these things feel maybe like common sense, they're not always commonly followed, and I feel like there's value in being this formal about it and following the same exact process every time. Anyway, that's my spiel. Now I'll open it up for anything we want to talk about related to bug fixing or anything else. Helmut says, I love discipline steps, a methodology. Yeah, that's what I'm trying to make this into, is like a methodology that anybody can follow. Yeah, and even me, like, as I've demonstrated, as I've been talking about this stuff, I don't even always remember all these steps. And so I like to remind myself, like, oh yeah, I'm doing this right now. Oh, another thing I'll say is like the value in having the 3 distinct phases of reproduction, diagnosis, and fix is because another mistake people make is that they get confused. They get mixed up about, am I diagnosing right now? Am I actually fixing right now? All that stuff. And that just invites trouble when you mix that stuff up. So that's another value in doing those 3 things as distinct, separate phases. Okay. Well, I won't end the call just yet. I'll give, oh, Carl, did you have something?
Sure. One thing I grew up professionally in an IT consulting background, and one thing I do find interesting that's more common in IT, but I like to think about it in when I'm troubleshooting a development issue as well, is there's a standard in IT called the IT infrastructure library, and one of the things they do is they separate the idea of an incident versus the problem. So the incident is the thing that's causing the business outage, and the problem is potentially the underlying cause or a cause of multiple incidents. So the idea is always to, solve the thing that's blocking the business first, and then leave the issue open to then solve the problem behind that. So again, not that you should always, go right for the hack, of course, but if it's something that can get the business up and going, obviously that's much more important for the business that you're potentially operating for than going down and figuring, okay, what's the root cause, how do I improve it, everything else. So one of the things I've always found useful is to separate those 2 ideas, like fix the incident first and then come back and troubleshoot the problem.
Oh yeah, that's a great point. Yeah, because like there are cases where there's a symptom. Yeah, so the terminology that I've used in the past is symptom and root cause.
Mm-hmm.
There are cases where a bug causes a certain symptom, and maybe you can fix the symptom without having to know what the root cause is yet.
Correct.
And I think what you're saying is if you can fix the symptom and stop the bleeding, then go ahead and do that, and then you can do your root cause analysis.
Absolutely. Yep.
Yeah. Yeah, and a lot of this is like an economic question. Like I've done this sometimes, like okay, so we talked about guessing and how it's not always great, but if it's cheap to make a guess and you might get a payoff from it, it's like if I can buy a lottery ticket for $1 and I have a 10% chance of winning $1 million, I'll absolutely buy that lottery ticket because the math works out for that. Because on average you win. On average you come out on top. And there are cases where even there's a bug fix attempt that I can apply to production. And even though I haven't diagnosed the root cause yet, this fix is cheap enough to apply that it's worth making that bet. And, obviously you don't want to do something that risks introducing a new problem. But it's the analogy to like buying a lottery ticket for $1 where you might win $1 million. It's like, okay, that's so cheap to do, and the potential payoff is so great that it's worth doing. And maybe a better like it's like a 50% chance of winning $1,000 or something like that. because it's like, oh yeah, of course I'll pay a dollar for a 50% chance of winning $1,000. So if I can do a bug fix where it's like, I know I'm just guessing, but it's so cheap to apply this fix and it doesn't hurt anything, then let's just do that if it's like a time sensitive enough thing.
Right. Yeah, I think one of the classic examples is if you have something like a memory leak or performance issue, if the reboot is a cheap substitution, to get everybody back up and going, by all means do the reboot and then troubleshoot. Then see if you can analyze the root cause later, right? Or make a duplicate into test and see if you can overload it then and get the thing to happen and reproduce it off production.
Yeah, the reboot is another one of those like cheap lottery tickets. Yeah, there needs to be like a better, because there's no real world equivalent where you can buy a lottery ticket for $1 for a 50% chance of winning $1,000. But that's, it's funny how often like rebooting anything fixes the problem.
Yeah, especially your more insidious ones,
Yeah. Will says, sometimes guessing is a good way to get started. Getting some momentum doing anything helps you start thinking creatively. Yeah, I agree with that. I think of that Theodore Roosevelt quote where he says, in any time of decision, the best thing to do is the right thing. The second best thing to do is the wrong thing. And the worst thing to do is nothing. And like, when I think the worst thing in programming is being in a state of stuckness. And when people are just sitting there stuck, then that's bad. And I think almost anything you can do to get unstuck is better than just sitting there being stuck. Okay. Anything
So I
else?
had another thought, if I could add some complexity, just to add another dimension. Sometimes the code is so difficult to read that you have to refactor and clean it up even before you can start looking for a fix. That's often been my experience. The bug is there, not because the code is simple, it's because the code is complex. And I'm afraid to change it because I don't want to break something else. So I've spent more time cleaning up, refactoring, simplifying, so I can find the bug. And it's kind of meta, but I've spent a lot of time. I don't know how that fits into your steps because it's sort of like it's a pre-step almost.
Yeah.
It leaves the code in a better place and it fixes the bug. It takes a lot of time though.
Yeah, that's something I definitely do. And Ben Orenstein said something really great about that. He said something like, the cleaner the code is, the harder it is for a bug to hide. And so I definitely have done that, clean up an existing piece of code. And I can hardly say it enough about the atomic commits. A lot of times I'll like add some tests and do some refactoring and get that out there, get that merged, get it on the books, and then come back, and as a separate piece of work, I'll do more diagnosis. And I might even have several rounds of that cleanup stuff, because that cleanup stuff is going to be a positive change independently of even diagnosing the bug. And then when I finally do find the diagnosis, I do that as a separate thing. And then another thing I've done sometimes, I learned this from Michael Feather's book, I will do like what you might call scratch refactoring, where it's like I'll refactor something with no intention of ever keeping it, but I'll just push stuff around so I can maybe understand stuff easier. And then I'll find the bug and I'll say, oh, okay, now I can see that this is it, revert, and then just apply that little bug fix. Anything else? Okay. Well, thank you guys for being here. This is a topic that I've wanted to talk about for a long time. And I'm sure there's even more. I'm sure there's 10 times the amount of stuff we talked about tonight that could be discussed. But I guess what I want to leave you guys with is reproduction, diagnosis, application of fix, those 3 phases, and then that binary search debugging method. It's easier to find where the bug is than what the bug is. Those are the couple things that I want to leave you with. I'll also say this, unrelated to anything we've talked about so far. Someone earlier today prompted me, you know who you are. I don't want to put you on the spot. But somebody prompted me with the idea of doing group consulting. So I've been offering one-on-one consulting, and I have some clients I've been working with on a one-on-one basis, but there's often a gap between what individuals can afford and what is justifiable for me. And an idea that I had that somebody else brought to me also is, what if people could share that cost so that as a group it's affordable for each individual person, and but then it still makes economic sense for me also. So if anybody thinks they might be interested in that, I guess just know that I may be offering that service soon, as long as there's enough people interested in it to make it work out for everybody. Yeah. All right. Well, thanks again for coming, and I'll see you guys all next time.
Thank you, Jason.
Thanks, Jason.
Good night. Thanks, everyone. Nice